So this question is asking us to show that a particular language is not regular. And this language, which we'll call L, is the set of all strings of the form W1, hashtag W2, hashtag, so on, terminated by WN for some n greater than 2, where each substring WI is some binary string, and some pair of substrings WI and WJ are equal. So in order to unpack that definition, I'm going to give a few examples of strings that are inside the language and some strings that are not. So an example of a string that is inside the language is something like 0, 0 hashtag 0. So 0 hashtag 0 is inside a language. An example of a string that is not inside the language is something like 1 hashtag 0. So clearly this string is not inside a language because 1 is not equal to 0. So now that we've understood something about the structure of this language, we could create a fooling set for this language. So just to recap, a fooling set F is an infinite set of strings W1, W2, has to be an infinite set of strings such that any pair of strings inside the language has a distinguishing suffix. So a distinguishing suffix Z is a string such that if you append it to any pair of strings, say X and Y, inside of the fooling set, one of them is going to be inside a language and the other will not be inside the language. So all we have to do now to show that this language is not regular is to come up with a valid fooling set for this language. So just as an example, just to show, to work on this the examples that I've shown you, we could basically restrict ourselves to the case where n equals to 2, right? So all these examples that I've given you so far are for the case where n equals to 2, right? And basically, we could restrict ourselves to this number because it's the minimal. It's the set of strings with basically minimal complexity that we could use to solve this problem. And one of the most straightforward ways to solve this problem is to consider the set of all the strings containing more than 1 0, basically. I mean, the set of all strings that are like some number of zeros. So why is this a valid fooling set? Well, because let's say that you pick some arbitrary strings, X and Y, from the fooling set. So we're gonna let X and Y in the fooling set, and we want these strings to be distinct. So without a loss of generality, we could say that X is equals to 0i, and Y is equals to 0j, such that I is greater than, actually smaller than j. Now we need to come up with a distinguishing suffix for these pair of strings. And what is the very simple way of distinguishing these strings? Well, we could set z to be equal to x. So let's see what happens if we append this string onto x, right? So x, z, is going to be 0i. Oh, actually, I forgot to put the hashtag over here. So let's see equal to hashtag x. So then xe is going to be 0, 1, hashtag 0i. And clearly, these two strings are equal. So this language, I mean, this string is going to be inside our language. On the other hand, yz, which is going to be equals to 0 to the power of I, hashtag 0 to the j, well, this is not going to be in the string because these two are not equal. So we just established that our fooling set is a valid fooling set for this language. So we can conclude that L is not regular. And that's all there is to it for this problem.